Afternoon, everybody. This is Jeff from Rust Bucket Valley Garage. This is part 2 in our Engines 101. This is a next generation engine. This is a 2.2 liter Chevrolet engine. Came out of an S10 pickup truck, and it's been partially stripped down. Generally, when you'll see it, it'll just be the block assembly, the bare block assembly. I've stripped this down a little bit further so we can take and get to everything a little bit quicker and give you a little bit of education in a short amount of time, so that when someone's talking about an engine, you'll know exactly what they're talking about. On this area right here, you will have the intake manifold that mixes the air and fuel and puts it into your engine. Since there is no carburetor on this, you will have fuel injection. So you will have a fuel injection rail that will be integrated into the intake manifold. This area right here is right where the oil filter screws on. These holes here, there's a bracket that goes on there that holds the alternator, which will appear right here. This right here is the port for the cam position sensor. They really started getting a lot of instrumentation on these engines for the engine control module to take and really check on the engine, see how it's doing. This right here is the crank position sensor. There is no distributor on this engine, so everything is done electronically. You will have the plugs that will be in the engine, the spark plugs, and you'll see them on the other side here. In these areas here, 4-cylinder engine, 4 spark plugs. The exhaust manifold will be on this side. When they take and make these engines blocks are made by a process called sand casting, where they have a machine that has a mold that puts a sand mixture with epoxy in it, and then it leaves gaps for the metal to flow into, and then you will see all of this engine block will be the finished product after they take and they melt all the sand out, and the cavity will be just what the engine is. So there are internal water jackets that the engine must have for cooling. These are called freeze plugs, okay? And there's some on both sides. What they do is they'll put this in a vibration machine, and then they will take and break up the rest of the sand that is inside the block, and then it will come out here. And since when the engine is in production and being manufactured that they can be a regular engine, these are plugged up. If you were to take these out while the engine's in operation, water would come out, coolant actually. This right here is where the thermostat goes. The thermostat and thermostat housing are important in cold weather climates, so that the thermostat is a thermostatic device. It's about this big around. It's got a thermal element and a spring in it. Goes in there. It holds water inside your engine to take and keep it in there till it reaches operating temperature, which is about 165 to 180 degrees, depending on your engine. And it will bring your engine up to operation temperature, so your air-fuel mixture will act more efficiently when it's being burned. This right here is a water pump, and this right here is the timing chain cover. This right here is the outlet for the top radiator hose. So you can see there's a plug right here where a distributor could take and be possibly used. If you take that plug out and you look down into that hole, you will see a gear that is on the camshaft that in previous models was used to drive a distributor cap, all that, and it'll have single wires that will go over the top, one for each plug. Okay, on this one here you have 4 coil packs, and they mount down here in this region, and then they are electronically controlled. There's 1 coil pack for each cylinder, 1, 2, 3, 4, 1, 2, 3, 4 coil packs. They are run by the engine control module, and they get a signal from the crank position sensor and also the cam position sensor. You can see by the back of the engine here, this is the output for the crankshaft, and this is the cam plug for the camshaft, and this is another one of those freeze plugs that I was telling you about on the side. It's an after thing for manufacturing the engine. In the front, I'll show you how the crankshaft and the camshaft are put together. This is more or less typical for the older generation engines, where you will have the cylinder head, and then you will have a cam, and the crankshaft will be in the block. Okay. For everything to run, there's quite a mechanical balancing act that must take place. This is a valve cover right here. This is one of the hoses for the emissions control system. This goes to the PVC valve, which is positive crankcase ventilation. It's a one-way valve that goes, it takes some of the gases that develop inside the engine, and it runs it back into the intake manifold, and it burns them so they don't go out into the atmosphere. For the earlier generation engines, they just vented them to the road, and that's why in the 60s smog was so bad. So if we were to move the valve cover, and we can take a look down in here, you will see the valve and valve springs that are in the cylinder head. These are called rockers. Okay, and they have various kinds you can have on here. You can take and get some high performance ones, and they have roller bearings in them and all kinds of stuff to take and make there's less friction in the engine. There are 2 rockers and 2 push rods. I will take the rocker off, and here's the push rod. So this push rod is hollow. This is how oil flows up. Takes and oils the top of the engine. If all these things take and run dry, they really start getting damaged. So let me take and remove the cylinder head off, and I will show you the other side of it. Okay, this right here is the inside. You're starting to get into the inside of the engine now. Okay, you notice that there's 4 cylinders, 1, 2, 3, 4. Here you see the spark plug that ignites the air fuel mixture according to what kind of signal the engine control module sends it. This right here is a larger valve than this valve is. That tells me this is the intake valve, this is the exhaust valve. The reason is the volume before it's burned will be a lot more than it is than after it's burned. You can see all these little holes and passages. These are bolt holes to take and have the head bolts hold the cylinder head on. These passages here, however, are for cooling, to keep the cylinders cool, and they're between the cylinders and then on the ends. There is no cooling passenger in this area. If there is, that is a problem. That would be a leak, and you wouldn't want that because you want the combustion chamber to be airtight, except when you want materials flowing into it. Okay, this right here is the combustion chamber, where you will see the cylinder walls, and this distance here is called the bore, B-O-R-E. A lot of common engines have a 4-inch bore. This is approximately 4 inches. The piston is down here in the bottom. Some engines have a tight tolerance between when the valves are fully open. Okay, so you will have, right, a valve lifter, which is like right down in here, and you will have a push rod go like this, and the cylinder head will occupy this area right here, so this will be poking up through the cylinder head, and then you will have one of the rockers on top of here, sitting on top of the cylinder head, and it'll this side here will be pressing on the valve stem. Okay, so all this is run by lifters, and obviously they're called valve lifters. This is one type of example of a valve lifter. This is where the yaw hole for the push rod is, and this is a roller type. They have hydraulic types, which are flat on the bottom and they ride directly onto the camshaft, and they have a hole, which is right there, that there's a little hydraulic mechanism inside here that makes the valve train act a little bit smoother. But as for wear on the cam, these are really easy on the cam because they're lubricated and they're rollers. So once they can talk to you a little bit about a common repair that's done. If you've gone to a repair shop because your car is not idling properly, idling rough, or you have water in the oil, which will be indicated when you pull out the dipstick or you take the fill cover off, and it has kind of a milky milk and coffee type color, it is most probably a head gasket. Okay, this is what they are talking about. This is a head gasket. This will take and keep a seal between the top of the engine and the cylinder head. Okay, when you take and change the cylinder head gasket, they should make sure this surface is really clean, because it's a precision mating surface. Sometimes when a vehicle has overheated, there becomes a problem. Okay, because the block here is made of cast iron. Okay, and the head is aluminum. So there is a different temperature rate of expansion. In other words, this gets hot and cold at a different rate, then this gets hot and cold at a different rate. So what you'll have sometimes is there'll be a crack in one or the other. If you have a cylinder head and you have a crack in there, it'll generally be a crack between the combustion chamber and one of the water jackets, okay, or here and here, okay. That can be repaired. You can weld aluminum cylinder heads. However, if you have a crack in the block and you have a crack between the cylinder and the water jacket, that's bad news. That's an engine. Okay, because this is cast iron, it doesn't weld very well. The reason it doesn't weld very well is because there's a lot of carbon in it, and whenever you weld it, it makes it brittle. So it's really a problem. Okay, so how do you keep everything in time? How does everything know, when to turn, when to shut on, turn on, when to turn off? Well, let me show you. On the front of the engine, where the crank pulley is here, where all your fan belts go on, I've went ahead and I've pulled that off, And this right here is called the timing chain cover. Okay, and that comes right off. That took a little more effort to get off than what I thought, but anyway, this right here is a timing chain assembly. Okay, so you have the crank gear, the cam gear, and this is the timing chain, and these are timing chain tensioners. Okay, this timing chain is in really good shape. It was replaced not too far before the head gasket went on this engine, and we just figured it had so many miles on it, we might as well take and just replace everything. When you are doing a timing chain job, these timing chains do get sloppy, and these guides do break. About the best timing components you can get are made by Moog, not a Spencer. I think a lot about their components, really like them. You have to take and make sure this thing is in time. Okay, there is a dot right there that has to take and line up with a dot on a tooth on this gear here with a straight edge from here to here, and then your engine will be in time. You don't have to take and drop a distributor in. There is no distributor in this engine. So what I may actually do is I may actually take this timing chain and the guides and the gears off and keep them for my own truck, you know. So, you know, these are in pretty good shape. 2 timing gears and a set of guides and a chain. It's about $94. So, and also Marcy's come out to help me. Hi, baby. Yes. But anyway, on this engine here, let me take and turn it over and show you what is different with the oil pump. So you can see here what I've done is I've tilted the engine up, and I've taken the oil pan off, and here is the oil pump right here. It has a gear mechanism in it that this is just a pickup right here. The actual gear pump is right here. It is driven off this shaft right here that runs off the camshaft. On the newest generation models, mostly those from Asia, Japan, Korea, the oil pump looks quite a bit different. This is one of the ones out of a Kia. The thing is like massive, so they really need a lot of lubrication in those engines, and you really need to keep everything cool, because everything on that engine except the hard parts, which are the cams and cranks, are made of aluminum. Okay, so you really got to take and keep them cool. But this one right here is driven off of the camshaft. This is the oil pump out of the Asian vehicle. You'll see that there's a gear right here that is part of the timing components, and they have a separate chain that runs that. Okay, so in the bottom here you'll see all these things hanging out of here. Okay, that is the crankshaft. This is what a crankshaft looks like. This would be the front of the engine. This would be the rear of the engine. This would be the gear on here for the crank position sensor. It's serrated, so it gets a pulse, you know, every time one of these little notches goes by it. Tells you exactly where the crank is in relation to everything else. Okay, these right here are called main bearings, and they support the crankshaft. There's also a seal here, and there's also a seal here that that takes and keeps all the fluids inside the engine. These lobes that are offset are where the pistons. This is a piston. Okay. Pistons actually go on here like this, and this portion of the piston rod here it's called the connecting rod. Okay, and obviously there's a bearing that goes in here that goes around this and allows it, when it's lubricated, to really slip around really easy. And then there's a bearing cap that goes on here. So sometimes these get bent. This is a connecting rod, bent connecting rod. Sometimes they break right here, and you will have a hole in the side of your engine as a result of that. This is the actual piston right here. This is called the wrist pin or connecting pin. You will notice that on here there are 3 sets of rings. There we go. I think that focus is okay. There are 3 sets of rings. The 2 top rings look like they're solid metal with a gap, and then the 3rd ring looks like 2 smaller rings with a serrated media in between them. The bottom ring is an oil ring that, as the crankshaft is going around inside the engine, it splashes oil up inside the cylinders. That 3rd ring there wipes it back down. The 2 top rings are called compression rings. Sometimes you'll get a broken compression ring. It'll take and score up the inside of the cylinder, make it look really nice. That's an engine job. You have to take and bore it out. If your pistons do not fit inside the cylinder correctly, you'll have wearing like this. This is called piston slap. Okay, there's a hard coating that is put on here. This is worn off by the pistons going up and down and moving in a direction that they should not, and wearing the coating off of the piston. So instead of tearing up the cylinder walls, it goes ahead and tears this up just a little bit. It's got a little bit of wear on it. The piston, or the coating on the piston, is kind of thin, and so these things are really, really lightweight. They should move really easy. So this is part 2, actually. So tomorrow will be part 3, where we show the latest generation of engine and how they take and make everything play well together in that. And I think you'll really be interested in it. Thank you again for tuning in to Engine 101 Part 2. Please subscribe, hit the notification button, and you will be the first to know whenever I put up new content. Okay, thank you for stopping by. Really appreciate it. I hope you have a great rest of your day. Talk to you later.